time is up, so any,
Oh my
any
God.
extra minutes, push us closer to 4 o'clock.
Okay.
I'm done.
Say what?
I'm done. He said any extra minutes will push it to 4 o'clock.
Oh,
Maybe
okay.
longer.
Okay.
I'm done. Yes, we'll look at that now. It's small there for that now.
Oh, yeah. Put your name on the, you put your name on the question sheets.
Oh.
Oh, we get 5 more minutes, and we'll have to be done. Question sheet, this was your question.
Oh, sorry. That's nervousness.
Name,
Name.
name.
Oh. Sorry. Mr. Moore, can we get these, the pressers? Get these back?
You will get them back.
Oh, okay.
So sorry. Would never guess. If you would have had the, you would have the patience to have a child. I would never think you would have the patience to have a child. But that's good. That's a good thing. Okay, that's it.
And then we see it, and then we do it.
Thank you very much. So considerate. Please put your names on your question sheet.
And I think
Put your question sheet with your people.
times that by divided by six. I get
The question, what's the bonus? The question, what's the bonus? You said only one. Okay. Let's see if we can move on. We have so much to do today. So. Orenthio, you get there? Orenthio is from the COB 201 class. He just wanted to meet all of you. Since you hear so much about each other. Okay, so first for the next half an hour or so, maybe even not all of that, we're going to talk about normal approximation to binomial. So we talked a lot about binomial in chapter 5, right? And we were able to, I think, get to the point where we could identify easily a binomial problem, right? So a binomial problem is identified how? By the existence of what? How do we know when we see a binomial problem?
Two-sided by.
Orenthio, don't be shy, you could also join.
Two-sided binomial.
Okay, so two events, right? I'm sorry, not two events. An event has to have no more than two outcomes, right? So yes or no, sleep or wake, here or there. So, and we said, well, once we knew that a problem was binomial, then we could use Bernoulli, right? Bernoulli process to calculate the binomial probabilities, right? And we said, well, the only time we could use that Bernoulli process to calculate those binomial probabilities is when the four conditions held, where there are only two possible outcomes from a trial. There are at least two consecutive trials. The trials must be statistically independent from trial to trial, right? And the probability of success must remain constant from trial to trial. So we said we know when a problem is binomial, and then we know when we can use Bernoulli, right? So what we're going to talk about today is, well, what happens in cases where you have binomial problems that are very problematic. Some binomial problems can be very tricky, and not tricky in that the observation of them is tricky, but that finding the outcomes and calculating the probabilities can be very difficult. So let's say you have a scenario where you know a problem is binomial, and you're asked to find this. You're asked to find what is the probability that x is a number. But let's look at two ways. Let's say you have this. You have somebody told you the number of outcomes or the number of observations in the data set is 90. And they want you to find the probability that x is greater than or equal to, let's say, 75. Right? So you end up, and let's say they told you the probability of success pi was 0.43. And they said, well, and you're trying to find what is the probability of success, what is the probability that x is a number that is greater than or equal to 75. So that's your probability. Well, you know immediately, Orenthio, right? You know immediately, you can't go to the table for this because this is not going to be in your table, right? There is no value for 0.43 in your table as as pi. I think your book uses mu, if I remember. Okay. Also, clearly you're not going to be able to go to the table because I don't think your table goes anywhere near 90, right? So you have a number of issues with this binomial problem. So the smart person would say, well, clearly I know it's binomial. I've already been through the 4 processes of Bernoulli, and so I'm going to try to use Bernoulli. And so you're going to say, well, let's use a Bernoulli function where the probability of x is equal to n factorial, x factorial, n minus x, factorial pi to the x, 1 minus pi, n minus x. So the smart person will, well, let's just use that. But you're going to say, well, when I use this, what do I have to do? Well, this is asking me for the probability that x is at least 75, which means that I need the probability of 75 plus the probability of 76 plus the probability of 77, all the way to what?
90.
Probability of 90. So you might say, you know what?
That's a lot.
You might say, you know what? This is a lot to do. But Orenthio says, you know, I just got off of work. I have nothing else to do all day. I'm just going to calculate them. It makes, it's fine for me. So he sits down and he tries to do them.
See?
So
Go
he's-
COB.
So he starts with the 75 one. So he says the probability of 75 then is going to be equal to what? 90 factorial over 75 factorial over 90 minus 75 factorial times 0.43 to the x, which is 75, times 1 minus 0.43 to the 90
He just saying
minus
people don't have the time to do
75.
that.
Okay, so he says I'm going to do it.
That's a long.
Yeah, I don't watch.
And then he throws that in his calculator, and what happens?
You end up with a big number.
You end up with not just a big number. You end up with a number here that you can't even interpret. Your calculator won't even do. It's a
Error.
huge number, right?
Wrong.
So, in this case, even if Orenthio tried to do this, unless he's sitting down in front of Excel or Minitab, it's not going to be able to do it. Okay? So what do you do then? Well, this becomes one of those problems where because this number is so big, because this number is so large, instead of trying to work this out as a binomial problem, you're going to try to convert this to a normal distribution. Okay? So that's one scenario. First scenario, hand calculators won't work for this binomial probability. And let's say, okay, let's say we abandon this problem then, because hand calculators won't work. But let's say now somebody says, well, here's another problem. Here's another problem. So now the probability of success, pi is 0.43, n is 20, and x is 11. This is still a binomial problem, right? Now, in this case, clearly you're still going to use the same Bernoulli function, right? But now you're going to find the probability that x is equal to what? So the probability that x is greater than or equal to 11 is equal to what?
Well,
Plus all the way to,
90.
20.
20. Oh,
right? So, in this case, Yehimo says, you know, this will work. These numbers are small enough that your calculator can do that, right? This will work. So maybe I'll sit down and do this for the rest of the afternoon, right? But that's tedious. It's tedious and time consuming, right? You will have Excel Minitab, sure you can do it, no problem. But in this case, this is very tedious and time consuming. So what I suggest then, I say, well, you know what? Rather than A, trying to stress out over something that your calculator won't do, or B, trying to do something that is so tedious. Because even if you try to do this the other way, where you said, well, you know what, we've done this before. So I know the probability that x is greater than or equal to 11 is the same as 1 minus the probability of what?
10.
0.
Of, yeah, let's go the opposite way, 10 plus the probability of 9, all the way down to the probability of 0. I still don't want to do either of them. They're both tedious. Either way I look at it, it's tedious. Right? Any direction I take it in is tedious. So I'm suggesting, well, rather than trying to do this, because your calculator won't do it, or secondly, try to calculate these very tedious binomials, then perhaps we can use this new technique we're going to learn now, which is called normal approximation to binomial. Okay? Now, Gregory, before we do this, let me just say, and I know Renthio can, I think, support me in this, that I've said this, it's right, in your class as well. Just because we are going to learn this technique for normal approximation to binomial does not mean this is the solution to every problem going forward. Okay? That does not
That's
mean,
a disclaimer.
I am telling you, that does not mean this is the solution to every problem going forward. You are only going to use normal approximation to binomial in one of these two scenarios. Because clearly if a problem is binomial, you should calculate it. You should calculate it as a binomial problem, right? But in these two scenarios, you could see the reasons why you would not want to go that way. So in these two, and only in these two cases, unless, like on your quiz just now, where you were told to use normal approximation for these problems, then you could use it. Okay, so these two scenarios only, or if you're told. Otherwise, you calculate binomial as if it's binomial. Okay? So let's look at this example to get started, and then we'll use this to take us through the procedure. Still chapter 6.
Oh. Oh, I do. 243.
Duncan, try to contain yourself.
Yeah, well, they are.
You excited?
No. Gotta focus.
Yeah. So let's look at this problem. Okay. A Myrtle Beach resort.
What result?
A Myrtle Beach resort has 120 rooms. In the spring months, hotel occupancy is approximately 75%. After your exam paper downstairs. In the spring months, hotel occupancy is approximately 75%. Part A. What is the probability? What is the probability that at least half of the rooms will be occupied on any given day? What is the probability that at least half of the rooms will be, yes, at least half the rooms will be occupied on any given day? That's what's exactly. Okay. So, binomial problem? Yes or no?
Yes.
How do you
When I
know?
have two of the rooms will be occupied, so it's two scenarios. Either they will or not.
Right, either the room is going to be occupied or not occupied. What is the probability that a room is going to be occupied?
It's half the room to be occupied.
The occupancy is 77%.
Probability,
Yes.
right? So the 75% chance that a room is going to be occupied. So you know that it's binomial because you know that there are only two possible outcomes from any event, right? Any trial, you go to a room, you choose the room. Is this room occupied? Yes or no, right? Then you know the probability the room is going to be occupied. It's 75%. So you have enough information to claim that this problem is binomial. And if you think through the four pillars, you can clearly see that there are at least two consecutive trials, right? Because you have 120 rooms, you have 120 consecutive trials. The probability of success is known and it's constant from trial to trial because they didn't give you a second one. The trials are statistically independent. We have to assume that, right? Because the outcome of one room being occupied is not normally affected by the outcome of another one. And the fourth one, statistical independence, you have to assume that as well, right? So we say, okay, well, we can clearly then try to calculate this as a binomial probability using Bernoulli. It's going to be impossible, right? As soon as you put 120 factorial in your calculator, you're going to get an error. So that means that this is a very good candidate for normal approximation to binomial. Now, as with everything else, and I'll tell you guys the other day when you got mad at me, I don't know why, because I kept telling him about procedures, right? I'm gonna always tell you that the easiest way to get through all of these problems is to just follow a very simple and clean procedure. We developed a very nice procedure for the normal distribution problems from chapter 6, right? Very clean. You write the probability down, you write the z, right? Calculate the z, draw your distribution, shade where you need to shade, plug in your area from the table, then do your calculation whether you're adding or subtracting or whatever you're doing, alright? It's a very clean procedure. We want to do exactly the same thing for these normal approximations. We want to have a very clean and straightforward procedure that you do the same way, that way it becomes repetitive, and that's why your other favorite word, mechanical, right? So, in this particular problem, some of the other normal normal approximation binomial problems will give you a hint that this is what that is by telling you to calculate the mean and standard deviation. Because clearly, if you're going to use the normal distribution, you need to know what the mean and standard deviations are to calculate z. You need that. You don't have it here, right? So the first thing then for the normal approximation is, this is part A. First thing, calculate mean and standard deviation. So mean is equal to what?
NP.
So NP, and what is N? 120?
120.
Yes.
P is? So what is that?
90.
90 flat?
Yes, sir.
Yes.
And variance is what? N times P times 1 minus P?
190. So you could just say 90 open close bracket.
Yes.
Times that by 0.25.
Yes. That's equal to?
22.5. Then you square root that.
And so the variance, the standard deviation, then it's the square root of the variance, square root of 22.5 is equal to
4.74.
4.7400 flat?
I mean, no, 4.743.
7434.
7434. Okay. This was 0.5 flat?
Yes.
Yes. Okay. Remember, try to keep these things to 4 decimals. Okay. So calculate mean and standard deviation.
Mr. Roll,
Yeah.
the 0.25. 90 times the
That
0.25.
comes from the 0.75.
Because
0.75,
The
okay.
difference.
Yeah,
This is 100.
0.75. No, I'm just trying to keep up with you, you see? Yeah.
oh, my bad, I should have
You don't want us to
Thanks,
write,
Dennis.
right?
It's a long way.
Mm-hmm. Yeah, that's why I know
I
even
get
though
it.
it's obvious, I still try to write it out long because some people will not follow where that 90 came from or even whether 125. But anyway, once you've done it enough times, it becomes repetitive again. Okay, so now that we have the mean and standard deviation, I want you guys to not write.
Yeah, that's it.
I want you guys to not write.
You don't like your right. It makes sense.
Yeah, I will give you time to write it down. So, once we've calculated the mean and standard deviation, which clearly we're going to need to calculate Z, next thing to do, write out what the probability is. They ask you for the probability that X is what?
At least half.
At least half of the rooms, right?
Right.
So that means you're gonna need 60, 70, 80, and so on.
Okay.
So that means that you need that the probability that X is a number that is at least
Equals to
60. So, now, here is a problem. Here is a problem. The problem is that this binomial probability is discrete, right? Which means that I might not be able to use this marker. Which means that you have these observations in this discrete probability distribution that look like that. Right? So that means that you know precisely where 60 is, right? You know precisely where 60 is. 60 starts here and it ends there. 61 starts here and it ends there. 62 starts here and it ends there. You know where these things are. You know where a room is. You know a room is here and here, here and here. You know a person is here. You know a person is here. A table is here, so on and so forth. These are discrete things. And we know that the binomial distribution is a discrete probability distribution. In fact, it's a family of discrete probability distributions, the shape of it being n and pi. What are we doing, however? What we're doing is we're trying to say, you know what? Because I can't solve this problem as a binomial one, I'm going to try to solve it as a normal distribution. In order for me to try to solve it as a normal distribution, that is what I'm trying to do. I'm trying to determine whether or not this distribution that is binomial has a shape that is sufficiently bell-shaped, sufficiently symmetrical, and whether or not I can assume that even though I know where one observation starts and one observation ends, that these things are close enough together, that even though I know where they are, that they're close enough together, that I can start to assume some, what we call continuousness, right? Some level of continuousness, meaning that there's enough observations that they're close and tight. In order for us to know that that's the case, we have to do a couple of things first. So, once we say, all right, I need to figure out what this probability is, the next thing we need to do is test this for what we call girth, size, and symmetry. So the next thing I'll do is I'll say, well, is n times p and n times 1 minus p both greater than 5? That is this binomial distribution large enough? That means, does it have a large enough mean? And does it have enough symmetry that I can say that this thing is going to easily approximate the binomial? Well, let's see. So we already know that n times pi is 90, right? So 120 times 0.75, we already know that's 90. And so 120 then times 0.25 is what?
22.5.
22.5. So 120 times 0.25 is 20.5?
Oh, no,
No, 90
no.
point times.
I'm sorry. 120.
Is that supposed to be the 90 or it's still calculated to 120?
30.
Oh.
30. So the question is, are both sides of this requirement at least 5? The answer is yes.
Yes.
Why 5 is?
That's an empirical rule.
Okay.
Okay, that will not change. That's an
Okay.
empirical rule.
Alright.
Okay? over thousands and thousands, millions in fact, of trials. Chevy has been able to determine that number, once that threshold is maintained, it's greater than that this looks bell-shaped enough and is tight enough that the binomial can be approximated by normal. So the answer to that is yes. So that means, great. Now I can go on and try to calculate my probability. Probability that x is greater than or equal to 5, greater than or equal to 60. Which we said then means we need 60, 70, 80, and so on. Now, once we've gotten to this point, we have a small problem again. The other problem here is that you are being asked to find 60. Right? You're being asked to find where 60 starts on this normal distribution. Because we've already said we can use the normal distribution because these conditions hold, meaning that it looks normal enough that we could go ahead and use the normal distribution. This binomial distribution is symmetrical and tight enough that we could assume that it's going to be easily approximated by the normal. Problem here is that now you're being asked to find exactly where 60 starts. Now we've said before in chapter 6, right, that I know the mean is there, and let's say 60 is there. Well, even where that dot is, where I'm saying 60 is, has an infinite number of outcomes underneath that dot. So we don't know that 60 is actually there. Only thing we know is that 60 is somewhere on that dot, but not where it is on that dot. So, because of that, we have to then convert this discrete number into an interval so that we know that we give ourselves some leeway to determine where 60 might be, because we really don't know where it is. That's why this is called approximation. We don't know exactly where it is, but we need to give ourselves some leeway. The way that happens is by building an interval around the 60 by simply adding or subtracting 0.5 from it. Either adding or subtracting or both, depending on what you're doing. So in this case, Elkin, since they've asked us what is the probability that x is at least 60, meaning that x has to start at 60, we need to then say, in order for us to know where 60 starts, we have to start at 59.5. We're always going to use a correction measure of 0.5 in either direction, but we just need to make sure that we know which direction we're starting in. Should this be 59.5 or 60.5? You need to make sure you understand why. So in this case, they said I want to know where 60 starts, because I want everything at 60 and more. Which means it can't start at 60.5 because you would miss 60. Right? Because you're here and you're going that way.
Right.
So you would miss 60. So once we know that, okay, our correction measure to start to know where 60 is at 59.5, now we just go and calculate z, and everything else is the same. So now we say, okay, well, what is z for 59.5? Well, that's 59.5 minus the mean of 90 over 4.7434. And so what is that z? It's going to be a fairly large number.
Negative 6.429.
Negative 6 point.
3.
Round to decimals.
Negative 6.43.
6.43.
Negative 6.43.
0.
Okay, so 2 decimals thing, 6.43. So then, what do we do next? Plot the distribution. Nothing changes from this point on. Okay, next thing, plot the distribution. And so negative 6.43 is gonna be all the way over there, we know. So we're gonna found it over here. So negative 6.43. So they're asking us to find what? Everything that is at least this, right? So that's going to be what?
To the left.
Everything that way.
To the right of it.
What is this then going to be?
0.5.
0.5. Yeah, clearly 0.5. So the probability then that x is at least 60 is going to be 0.5 plus 0.5 is 1.
It's plus because we're going to the right.
At least. Instead of
It says at least.
So you want everything
Where
or-
you are, so you want everything that way. Okay, so that one was easy. Let's look at part B. Part B says, what is the probability that at least 100 rooms will be occupied? What is the probability that at least 100 rooms will be occupied? Okay, so clearly there's no need here to calculate mean and standard deviation again, right? We have it. We don't need to do the Girth test again, we have it.
Yes.
Right.
So we just need to go straight to the probability. So what's the probability that x is at least 100?
Yeah.
So how are we going to adjust this?
99.5.
That's be 99.5 because you want to start before 100, right? 'Cause you're going to 100 and beyond. So it's going to be 99.5. So Z for 99.5 is going to be 99.5 minus 90 over 4.7434.
No, this was no.
Do you want to participate? He wants to participate?
No, Mr. Lord, I don't want him to get too advanced.
And
I
also,
didn't have the issue with him right now in school, so I don't need to empower him any further.
I can't take it. 0.00.
Disempowers the child.
No, Mr.
Anyway,
Lord, the things we
I have no
do-
children. I don't know.
You don't?
No.
Oh my God.
That bad is thrown.
2.00.
2.00. Don't need that in my life.
Oh my
Right
God.
now, no. Okay. So 2.00. So that's going to be positive here. And so they're asking the probability that x is at least that. So what are we going to shade?
Between mu and 2.00.
No.
No.
X is at least.
Oh, at
So
least.
that means it's to the right.
To the right.
From
From
the
the
right.
2.00.
So that means you're gonna have the minus from the
The
0.5.
tail.
Yeah.
So what is this then?
Oh.
0,
4.
4.4772.
Yeah.
0.4772. And so how do we gotta find that then?
That's 0.5 minus 0.4772. Let's see.
Equals 0.0228.
0.0228. Good. So part C. What is the probability that F is no more than 80? What is the probability that no more than 80 rooms will be occupied? Gregory?
Probability, okay, that's less than or equal to 80.
Less than or equal to 80. Good. Adjust to
Adjust to 80.5.
80.5. How do you know this one should be 80.5?
Going opposite direction.
See,
Because we know we want 80
Because
included.
you want to include 80.
Right.
Yeah.
You want to make sure you include 80.
Right.
Right?
So
So
you
it
go
won't-
beyond
it's
80.
no more than 80 rooms, so you need to make sure you include 80 though.
Right.
So you gotta go a little over.
So you go a little over, so you make sure you include 80.
Is more.
X is no more than 80 rooms.
No more than
No
80
more than
rooms.
80.
Alright. It's no more than 80 rooms.
80.5 minus 90 over 4.
So Z for 80.5 is 80.5 minus
90
90 over
4.7. 434. 0.5 minus 90 divided by 7.434 minus 2.
minus 2. Negative 2.
Yeah, minus 2.
Oh, we have better than
So we have them already.
So now it's just on the negative side?
Mm-hmm.
Right.
So what are they asking you to find?
Everything past the negative.
Everything passed. This had further, so you go in.
So
The
no.
left side.
No
the
more.
left
So that means it gotta be the left. So
Everything
from
to the left.
to the left.
So it's in the tail.
Yes.
And it's the same.
Same thing.
Same answer from Z.
So this is here, 0.4772.
772.
So that means then that this has to be
0.5 plus.
Minus.
I mean
Minus
minus
0.4772
0.4772 equals.
0.0228.
okay. And then finally part D.
We can write this
Maybe
first.
we can write first.
Um,
No space for D.
okay, go ahead.
Thank you.
Just let me squeeze it. Let me warm my coffee.
I just catch myself. Take a picture.
Yes. Hey, Desiree.
Hey.
So my son did tell me, Daddy, the teacher said that his 16 tickets that they found that he sold during fun day so that he can be a baller. But it was actually 25. I'm like, so why are you trying to find more bills for me? Why do we need to get more? Then he said that it was actually 26, but he kept one in his drawer at home as a memory for testimony. The day that he had fun, he sold tickets that wasn't supposed to be billed to us during fun day. So you really think I need to make him any smarter than he is now?
Nope. I mean, yeah. You're never too smart.
The person that gave him $1, the teacher asked him why did he need the $1. She asked him if he had break. Since she didn't ask him if he had lunch, she accepted the $1. You really think I need that? I don't need it. I don't need it. I hope you pay attention. And see what it is that I'm doing.
Shit, you was big brother the other league, can't you know, and two big.
Oh girl, he likes maths.
Mm-hmm.
I mean, this was the bonus question here, you could get it. He's so maybe is.
Didn't do it.
You get finished?
Yeah,
It's in the bonus question.
That was the bonus question.
Which one?
Yes.
Yes.
It didn't the same way though.
But it's the
Yeah,
same
yeah,
formula
yeah,
because you
yeah.
find the mean.
But these
You're
just, these figures more bigger.
Yeah, you have to find the mean and you have to find what that bottom piece is.
Yeah, I see that part.
I know you penalized me for rounding off so soon, but
What is it?
is that right? I need these extra points to smile on me right now.
Shoot. I saved myself in the streets.
Do I look as though I'm that impatient, Mr. Road? Do I look as though I'm that impatient?
Go on, Sam.
Big for an answer.
Yeah, just,
Leave it, just say that's me.
Let's leave it there.
yeah.
Why give him that type of?
Parenting, I have a child, a 2-year-old.
See he's smiling, he's smiling.
Quiet.
See, say it. Okay, I'm saying nothing.
It's more like I was telling them that my son he sold some tickets during fun day.
Why you calling this business? Jesus,
I have to pay for them.
you pay for them. See, you step your turn, you know, back up. There, don't say nothing. Embarrassing. All the stays tomorrow, you need to get a gift. Save yourself.
I don't know.
You all have kids? No.
No, I have a
One.
2-year-old.
My daughter is
Of
11.
16 months old.
I have enough. I have enough to share with those who don't.
As long as in 9 months, we don't see another one. After that, honeymoon.
No, thank you.
Got the honeymoon. 9 months later.
Child,
My one
my
son.
daughter 11, and I don't have no intention of having no more.
You only have one?
Yes,
Yeah.
sir.
You need another one?
I have a 2-year-old, that's
I
enough
don't
to
know, Miss
start you
Penny
off
there,
with,
you
like,
know, she go over
If
there.
somebody comes to me with a logical reason why I need another child,
You
then
have
I'll go
you
get
supposed to
pregnant.
have a pair. One
Because
boy,
you
one
don't need to
girl.
be selfish, and then when you're not in this world, she needs somebody else.
Mhm.
I have
She's-
nieces and nephews.
No,
Not
no,
the
no.
same.
Husband.
You're blonde.
Next house.
Blonde.
Oh,
I need one more.
Oh, don't forget our discussion for last night. From last night. Oh,
Yeah.
I think I need coffee.
We're on the same page,
My
right?
2-year-old came like this.
You guys done?
No.
No, sir.
One more and
I'm
I'm
gonna get
done.
coffee and I go.
So Mr. Rose, when we are doing last stand, we want to go higher because we want to include the number. And when we go on graded land, we want to go lower.
Right, it depends on the
Trying to-
direction that you're going.
Yeah, I mean, it depends
See-
on what you would figures we
Yeah, so
have.
see here, this one is
Yeah.
saying it wants everything greater than.
So we
So you wanna
start,
make sure you start just a little before it. so
yeah,
you
and then
can
go up. And
right.
then if it's last stand, you want to include it and then go,
So it'll go a little over it,
Okay.
right?
alright. I gotta make up for that.
We went to tell about 8:20 and Mr. Rowe.
Yes.
I was ready for
Y'all had
vacation,
class
and then you were
last
gonna
night?
jump with
Yeah.
Charlotte, I called
Practice.
from 10 o'clock yesterday. He said, yeah, he coming. So
Like,
that's
no,
good.
never.
Yeah.
Some of the lines was busy, some of the lines was
I-
working.
Yeah, that's all.
good.
Wasn't,
The school lines.
I had to call the second line all day.
Yeah.
No, how they called the first time to cancel that we wasn't gonna have, and I said, okay, they called to say, yes, we are having.
No, we will always have it unless we say no.
Okay.
Yeah, so it's Friday. I'll have the next one. And then class goes from 9 o'clock.
You should come to on Fridays, we have a classes.
9 in the morning.
So this is gonna happen every Friday moving forward?
Saturday?
Yeah.
What time?
Yeah, that's what they said.
Okay.
And then you go for the service 12.
And that's just gonna be that's just gonna be like review and stuff like that, it's not gonna be anything new.
Yeah,
Okay.
3 or 4
But
hours.
those are helpful.
Yeah.
They need that.
So Friday again, so.
Oh,
Oh, so we're supposed to change class to 9 in the morning instead of 12.
Yeah, that's what I just finished talking to him about. He said he used to.
Exam.
Let's finish this, let's try to finish the question, then we can do all this
You know,
administrative
all
stuff.
kind of new things. Like, if you're lost.
No, we didn't go on through this. We just went through everything what he taught us last week.
I need to go to church.
That's a lot of it,
I
sorry.
need to go to church.
We didn't do that in class.
Oh,
That was the bonus part.
Yes.
oh, I messed it up.
Don't rub.
No,
Almost
Mr.
finished.
Rule, go do away.
No, no, no. Don't you dare do it. Sorry,
Oh.
not you. Not you, Mr. Rose.
Oh, the DDI though.
No, no. Come back.
What would this
We-
question value in the exam?
So exactly.
Because
It
you gotta
doesn't matter
find-
because I know like Miss Rowe had one simple equation that was worth 25 points. You know I was mad, right?
Are you guys done?
All type of wording.
Hold on, I just gotta draw the.
I need the
This-
bell
last
This time I read from here to here, but I still couldn't get it.
This one.
Alright, so one more section of this, do one more and then we'll be done. Alright,
Wherever you're ready, you just
Part
make it back
D.
in line.
part D says, what is the probability?
Just a question.
That
below.
What is the probability?
What is the probability that exactly
That exactly
85 rooms
85.
will be occupied at any given time?
Available at any given time?
Occupied at any given
Right.
time.
Yeah, because that makes a big difference.
Available.
If it says available or occupied,
Yeah.
that means that,
Yep.
that makes you look at it the opposite way. If it said
Yeah.
available, right?
So I gotta practice.
Okay, so, so this one then, what's the probability that exactly 85 rooms will be occupied at any given time? So they're asking you for this, right? Probability that X is equal to 85. Now,
Oh, we got an equal one.
right, now notice,
That's the same thing with
this could be equal because this is a binomial problem.
Yeah.
So you could find out where X is exactly
85.
for this binomial problem. But your problem is for this normal distribution. You can't really figure out exactly where 80 is. So this is a even more significant issue. So, what we have to do here then? Orinthia, what we have to do here? What would we have to do? Now, we're trying to find out exactly where 85 is.
So we need to keep 85. then.
So we need to make sure we keep 85. So what do we have to do?
Go before 85 and after.
Yeah, so we have to go both before and after 85. We need to build an interval on both sides.
Yes.
Right.
So we'll do, yeah, so we'll do 84.5
And
and
85.
85.5.
So 2
And that'll tell us precisely precisely where 85
85
is.
is in between.
Right. So we'll just do C then for 84.5. It's 84.5 minus 94.7434. And we'll do C for 85.5. 85.5 minus over 4.7434. 0.16.
Negative
Negative
1.16.
Negative 1.16.
And then the other one. Negative 0.95.
Negative 0.95. Okay. So plot. So they knew that. So they're both negative clearly, which is obviously. So negative 1.16. Let's draw it a little bigger than usual. And then negative 0.95. So that means that 85 then has to be where?
In the middle.
Between them.
85 has to be somewhere in here. Okay. So what is 1.16 from the table?
0.3770.
0.3770. And what is 0.95?
0.3289.
3289.
0.3289. So it's probability of 60, then it's gonna be what? Of 85 is gonna be what?
Equals. What is it?
0.3770 minus 0.3289.
Okay, that's
0.0501.
0.0.
Get that, bust it up.
You are there, right, just now?
That is. Hold on.
Alright.
That's right.
that's what you get?
0.3770
Minus
minus
0.3289.
481.
Yeah, that's
0.0481.
0.00481.
Yes. Good looking out there.
Kill me now.
No, no. Get ready, get ready.
Okay.
busting it up for this new time.
I won't
Exactly
sleep.
25 rooms will be of
Oh, we can write it down, Mr. Rowley.
Yes, we're gonna do one more problem and then move on.
Sounds wrong on about 1.16. Hey, can you look at 1 second?
Who's talking?
This is the question you're gonna go with this last night.
Huh?
This is the question you got to last night, right? I thought you did.
Okay,
Yes, sir.
let's go on to,
Hold on.
Right?
you are taking my long to write.
Sorry.
Mr. Roll, I'm sorry, your shadow's in my way.
See your shadow.
I didn't want to say,
Like
oh,
that.
what is there? Yes,
Like that.
I appreciate that.
I was trying to get more Louis.
Oh.
You made it funny.
I did. Okay, we're gonna do this one from the quiz.
Oh, man.
Please,
today?
yes.
Oh no, but then she haven't done it yet. Julia.
He could do me a different one, please.
Why would I do a different one?
Well, then don't give it
She
up.
haven't done it yet.
The rest of us had
Why
to
am
suffer the same.
why am I
way.
giving her an extra, why am I giving her the quiz?
Oh, she didn't take the quiz today.
So,
Oh.
what's that?
Oh, my bad, my bad, my bad. Sorry for that, boss.
It's the rule I called the school.
We were in class, nobody made any arrangements with me for
I
the
called the
quiz not to be
school.
taken.
Man, I did.
Sorry,
I
I tried to
called
get
the
this off
school,
fast.
Mr. Rule.
Wow, I did.
To speak with,
So, it says, assume that x is a binomial random variable. And that's
That's question 1, 2.
one.
One,
The bonus
the hard
question.
one.
Assume that x
Should
is
be
a
easy
re-
for the rest.
that x is a binomial random variable
Mhm.
with n equals 25 and pi or p equals 0.5.
Is equal what?
0.5. Same question.
Find the normally approximated values. Find the normally approximated values for these binomial probabilities.
What is binomial?
Probabilities.
So, and part A, what is the probability that x is less than or equal to 13? Okay, so we need to do stuff here. So Shapiro. Oh,
Me?
Shapiro, yeah.
Oh. C13. Oh, P, write the P first.
Yeah, before we get to that,
You have to do the
sort of
Oh.
procedure.
Cheese ain't going to have time.
For the meeting.
I'm sorry. I'm sorry. See what's going on, banana. U equals NP. That's the formula.
Mhm.
And then 25, I mean, open bracket, sorry, 25, close bracket, 0.5, yeah, bracket. And then we find the answer for that first.
Mhm.
12.5.
Yeah,
12.5.
Oh, he didn't put it.
Sorry,
He didn't put it
Mr.
there.
Rowan,
He just-
I know how to do it, but you know.
Yeah.
So, a little squiggly thing I forgot, yeah, that, NP, open bracket, 1 minus P, close bracket, equals, root 5, yeah, times, point five, sorry.
6.25.
Y'all have your glass, that's all.
Yeah, I said the answer.
Okay.
6.25. I mean, I remember.
Then we put the same squiggly thing down again, equals the square root of 6.2, I mean, yeah, sorry, the square root of
Equals
6.25.
2.5.
2.5.
Yes, sir.
Yeah.
Okay. So.
I can write it down, I can see it.
Okay. So Desiree.
Okay, so now you put NP and N open bracket 1 minus P.
Five. So
Yeah,
that's
5, always use 5.
Do we have to put yes?
Yes.
Okay.
So what
That
if we
is the word
forget?
fast.
What if we
Yeah.
forget to put that part in there? Will we leave minus points? Because if we forget to put NP and N,
Yes.
Yes, the answer is yes.
Yes.
Yeah?
That's
Then
yeah.
you put
Okay.
in,
Because now what you don't need to do, you don't need to go calculate that. I mean,
Yeah.
like, write that down.
But that
You
is a
can-
step that needs to be
Right,
included in
because
the.
this is telling you that this binomial distribution has enough size and it has enough symmetry that you could use normal. This is the test. Okay? So, yes.
so now we put in, open bracket 25, close bracket.
So it's a probability that X is,
Oh.
Greater than or equal to.
Greater, no, greater than or less than or equal to 13. You put-
less than or equal to
Yeah, oh
30.
yes.
Okay. So what do we do next?
Z.
No, you put
12.5.
13.5.
12.5.
We need to invert this.
13.5, find it.
Oh, that's what I said.
13.5. It has to be
13.5.
13.5.
Yeah, because it's
13.5.
less than, so you go up.
And then
yeah.
13.5 to less than
Orinthia,
12.
you agree? You go 13.5? Because we want to make sure we include 13.
13, yeah.
That's
That's right, yeah.
13.5. So Z for 13.5, 13.5. What's the mean? 12.5?
Mr. Rhodes, suppose I put Z score equals 13 and then I put equals 13.5.
Oh, that's, where? You mean on your paper?
Yeah.
Just
No, nothing major.
Okay.
Okay, what is this?
1 over 2.5, which is 0.4.
0.4. Plot the distribution.
I still minus the pizza.
So 0.4, positive side.
Yeah,
So what are they asking for?
the part to the right of the blue.
No.
No.
Left.
Oh,
Yeah.
that's
Shaded in
oh,
between,
it's shaded in
0.4.
between, yeah, sorry.
In between.
In between where?
Go to the left.
So everything to the right.
Everything to the
And to the left.
Everything to the left.
To the left,
What's
sorry,
everything?
yeah.
You want
Everything.
X to be less than
Then
equal to
13
this.
to
So that's
everything.
right.
Everything to the left.
Okay, so what is this?
So that's 0.5
0.5
plus
over
that.
there.
0.5 plus that thing.
What is this?
That's it, guys.
The table.
0.1554.
So
Almost.
0.5
5,
minus.
5. No, 0.5
I mean-
added.
I had to
Yeah.
put together.
Yeah.
Because that's
Sorry,
everything.
So that's
I
0.6554.
add.
Just adding and subtracting.
I think it's a trap.
It's a roll like mess up.
I think it's a
We
trap.
don't.
Okay.
Yes, that's a trap.
I subtract it also.
Part B. What is the probability that X is at least 15? Probability that X is at least 15. Yahima,
What
take
is
this
the
one.
probability?
At least 15,
Mhm.
so that'll be X greater than or equal to 15.
Mhm.
So you need to do score.
We need to equal 16, so it'll be 15 point.
14.
Less than 15.
14.5.
So be 14.5.
Yeah, you need to come this way because you're looking at 15 and going that way, so you need to be a little before it. So it'll be 14.5.
14.5 minus 12.5 divided by 2.5.
So 0.8 is that?
0.8.
Yes.
We can actually.
So this is positive 0.8.
Yes, 0.2881.
What are we shading?
That would be 15.
To the right,
From 0.8.
to the tail.
Okay. What is this?
And that would be
.2881. So you're minusing that from 0.5.
Minus 0.5. 0.21.
0.2119. Okay.
So my 15 minus.
And then part C, what is the probability that X is between 9 and 15? X is between 9 and 15.
No, probably a 9.
Mhm.
8.5.
So this one is going to be 8.5. Oh. So you want to make this 8.5 so that because we're starting where?
Starting at 8.5 and including 9.
So because we're going up to 15, right?
Yes.
So you're starting a little bit before 9, so you include 9.
You want to go beyond 15.
15.5.
And 15.5, so you can go a little beyond this, so you can include 15. So do we have 9 yet? No?
No.
So we need C for 8.5. 8.5 minus, what's it, 12.5?
Divided by 2.5. Negative 1.6.
And then we have 15,
Yeah.
but we don't have 15.5, so we didn't have to go over before.
Yes.
So C for 15.5.
Okay, so I was heading in the right direction.
12.5. Yeah. 2.5. 1.2.
Positive or negative?
Positive.
Positive, okay. What?
That was kind of close.
You didn't know it would go like that? I do like that.
Negative 1.6. Positive 1.2. 1.6. So we're gonna shade, yes. Where's 1.6?
1.6.
0.4425.
And 1.2.
0.4452.
1.6.
0.4452.
5.2.
Oh, 4.52, sorry. And 1.2 is 0.3849.
3.849.
And then you add them.
0.831.
0.4452 plus 0.3849 is equal to
0.8301.
0.8301.
It's about some months.
Okay, good.
I think I got that.
I ain't get the wall.
But I know I ain't getting the mark since I didn't put that curve thing.
Stop talking before you think you'll finish. Then look at the boy.
Mr. Roll, how about something like this as well?
Okay. 20 points.
20?
So this is one of them must do questions.
Yes. With no sense. Just trying to draw these things.
Excuse me, Mr. Rowe.
So Mr. Roll, for missing out NP and N, open close
Definitely take
bracket.
our points.
How many points would you take off for that?
Just focus on trying to get it right. In case you're worrying about the points and how many points you're gonna get and taking out. Don't worry about which points coming off. You want to make sure you include it.
Elkin just going through this class again.
I don't want nothing to do with
Yeah,
this.
but I-
Oh, boy, that's to do the class again, Mr. Roll. I don't
I
think
must
he's
be the
gonna teach
lecturer.
that. I don't think he's gonna teach his class. He'll be like, "Elkin,
I
this
must-
class?" No,
I
he
must
can't
be the
do it.
lecturer for this class. I think Mr. Roll will sit down and be like, Elkin,
Mr. Roll, I'll see you
Tell them
in
what you
301,
want.
but I don't want to see you again for 201.
I don't want to see any of you again.
You can see me again in 301.
I'd say for 201, I don't want to see any of you again for 201.
What?
so I have baby and I must be the lecturer.
No.
Hey.
How would I be able to get this included on Friday night?
Huh?
Friday.
Is he coming Friday?
I'm coming Friday.
You better try to call him then.
Call in again.
Hey, you need school, but you need a job. Pay your
Right.
bills.
Friday, you work Friday, right?
Yes, sir.
Remember, we're only gonna be reviewing Friday, it's nothing new.
I know, but I called him yesterday. I say, I don't feel well, my stomach going down one day. I had 4 days.
You don't lie on sickness.
No, because
You don't have a due date?
I have 3 left.
So why you doing it?
Okay, you guys done?
No, sir.
I don't like it that much.
I mean, only this last one
If
again.
it's my right, tell my supervisor, then have to deal with it.
That's why I went
If
above
it's in the
here.
books,
That's why I went above here and went to
Schedule.
the director.
you have to comply. Oh, I like throwing the book back at you.
But then, I mean, and I can complain and say that, hey, I've been working a lot of Friday nights consistently for over 2 months now.
You just told me the thing, but you said this is what I'm entitled to. What's
Take it out
happening
somebody
here?
to go for the 3 hours?
Yeah, I mean, I'm sitting here be like, so what am I gonna do?
Yeah,
But you said.
just information.
Some people don't think you're supposed to come and live. But I have 160 for the year.
Sure. I just my supervisor, I will come for the class.
So not about the last time around on the right place.
I have 12
What?
sick days.
We don't know that.
I haven't taken none of mine yet. I have 4.
They're not days to be taken in.
I mean, that's
I know
it.
this.
If you get some.
Days, yeah, people is acting,
They
days
don't-
days for long.
They don't come
Yeah.
sick days.
Some people's entitled to 6 days is this.
Like, yeah, these, I'm entitled to take
I have
these.
a coworker, every time after
The definition
vacation,
of sickness.
she's sick for 2 weeks.
What? Because you don't have a headache, I'm
Still looking
sick.
She's sick for the same 2 weeks after every vacation every year. Y'all look at the trend. She's sick for the same 2 weeks
What is this?
after every year.
Well, I can't talk because that happened to me a couple times.
Ooh.
No, I dislocated my shoulder once.
Oh.
And I
You are
damaged my
bad
knee.
reason.
And I damaged my back.
So-
Yeah, but this
you
one
do
hers was intentional.
This girl was exhausted.
So-
She said she suffered from
So
exhaustion.
after every vacation, I had an additional 2 to 3 weeks.
Okay. So now we're gonna talk about sampling and sampling distributions. This is pushing us into chapter 7.
Okay.
So, now this is the first time, for this class that we're gonna move away from looking solely at a very theoretical set of circumstances to something that is very real world. These are very, this whole area on sampling and sampling distributions is very empirical. Okay? This is all empirical stuff. Meaning that these are all things related to real world scenarios. Because I think I mentioned earlier in the class that, well, we talked about samples versus populations. And we said that samples are just a subset of the population, right? You all are a sampling of institute students. So if I wanted to know information or parameters about the population of institute students, I would have to go and get every single person's profile and find out their grades and find out this stuff about them, and then calculate some parameters. That is a very difficult thing to do, primarily because the information is usually very hard to get, and the information is usually not 100% accurate. So you'll find very few scenarios where people actually try to look at parameters, people actually try to look at populations. It's very unusual. Therefore, that's why this class exists, because for 90% of the cases, maybe even 95% of the cases, we're going to be looking at samples. And the way those samples affect the way populations truly look. So, if I said to you that somebody wants to take this class next semester, right, or semester after next, or whatever, and they come to you and they say, I want to take this class, but I want to know what sort of grade should I expect to get out of this class.
On average?
The smart person would say to them, well, what I would do is I would sample students who've taken the class already and sort of find out what the average grades were. So let's do that very generally. Let's say somebody goes and they sample 9 people from classes before. And let's say they found that the first person they sampled got an 85 in the class overall. Let's say the other person they sampled got a 63, and maybe the next person they sampled got a 45. Right? Then let's say that the other person they sampled got a 30. Somebody else got a 75, and another person got a 90. And let's say somebody else got something like a 65, somebody got an 89, and let's say somebody got a 73. And let's say now that this is the complete sample that this person got. Just 9 people, which was sufficient for them. The sample mean that they would calculate from this would be what? Let's run that through your calculators quickly. Tell me what the mean would be.
$68.33.
68.33.
Yes.
Okay. So this means then that any random person going into this class should expect their grade to be 68.33. This is expected, right? Even though we know what? That this number is highly theoretical, because this number doesn't actually exist. We say that over and over and over and over, and when we look at these distributions, the mean value doesn't actually ever exist in the distribution. So that means that if you were to plot this distribution as a normal distribution, right? That number of 68.33 will never exist in the distribution. That's why if somebody asks you, like, I think one of your questions did, in your quiz, what is the probability that a random selected jet will generate noise level of exactly 110 decibels when the mean was 110 decibels? The answer to that has to be 0. Right? Has to be. Because there's a 0% probability that an X value is going to fall on the mean. It's not going to happen. And if it happens, it's an infinitesimal probability that's going to happen, so it's going to approximate zero anyway. So, but now, let me ask this question. If this is what this person expects to get as their average grade, because this is the average grade from this sample, then wouldn't we expect then that if this sample, Horatio, is a representative sample of the population, right? If this is representative of the population, then shouldn't we also expect the population mean to be this?
Yep.
So shouldn't we expect that to actually be the case? Now, we don't know that that is actually the case. We don't know what the population is. But if we believe that theory, that this representation is real, then this makes sense. We should expect the population mean to look like the sample mean. So, what that means then is that this X bar, this sample mean, we're going from this point on, say that that sample mean unbiasedly represents, that sample mean unbiasedly represents the population mean. That whatever this is, we should expect that to be. It's unbiased. Now, if that is the case, then shouldn't we expect then that the mean of any sample means within this larger sample to also be equal to this 68.33? What I mean by that is that if I were to label these, if I were to separate these again into 3 sub-samples. So now, let's say I look at this as the population of grades, and now each of these 3 as samples, and I call this sample 1, sample 2, and sample 3. Then that means that this sample itself has its own mean, which is x1. This x bar 1, the sample here has its own mean, which is x bar 2. And this one has its own mean of x bar 3. So, what is the average of x? What is the average for the first sample?
180.
The average.
Sorry, 160.
60. Average. And what is the average for 2?
75.67.
75.67.
Yes, sir.
And the average for 3.
69.33.
69.33. So, we see there, right, that none of those is the 68.33. But what we do know, though, is that the mean of all of these sample means has got to equal that.
Yes, it does.
So if we were to take the mean of these, that has to be the case.
Yeah.
So here we have two. We have 2 unbiased estimators from mu. We know that the sample mean should equal the mean, and the mean of all the sample means should equal the mean. So that tells us that theoretically, of course, because we don't know what this is, really, that this relationship should be unbiased. That's very important for what we're about to do, because that theory we have to believe that for the rest of this to work. Now, what is not the case, Yehima, what is not the case is that the sample mean, or the sample variance, or the sample standard deviation, these 2 things do not unbiasedly represent sigma squared or sigma. That relationship does not happen, because the population standard deviation, remember when we calculated the population standard deviation, or when we wrote it, we said sigma squared is equal to what? The summation I is equal from 1 to n, after capital N, xi minus mu squared over n. But when we looked at the sample mean, so the sample variance, we said that that's equal to summation I is equal from 1 to lowercase n xi minus x bar over n minus 1. So those two things are not the same. And what that also means is that because this squared, and I don't want to get too theoretical on you, but because this event here is actually an exponential function, meaning that as you move further along this distribution that way, this event starts to look like that. It's serpentine, right? Meaning that it goes up very quickly, it sort of flattens out and pulls up very quickly again. That relationship is a very specific one. And so this here does not work. But what does work, believe it or not, is that this and this are very much unbiasedly estimated by that. Meaning that if you were to take the standard deviation, however, of all of the sample means, the standard deviation of the sample means will approximate the population mean. But the standard deviation of the individual values will not approximate the population mean. This is all very theoretical. This is just to give you sexy things to think about. But
Multinational, eh?
Yeah.
So
It's sexy.
yeah, it is very, right? So, but once we sort of wrap our minds around that, now we can start looking then at x bar as our random variable. Up to this point, every single random variable we've looked at was represented by x, right? What is the probability that x is this? What's the probability that x is that? What's the probability that x is greater than or equal to this? All of this stuff we were talking about x. That's because we were looking at one single observation somewhere in this data set. Now we're beyond that. We don't want to know whether or not some random variable that you put your hand on is going to be that. We now want to know whether or not some random variable you put your hand on is going to average this. It's an amazingly different thing. Okay? When we start to look at these problems from chapter 7, these problems from chapter 7 are going to look almost exactly like the problems from chapter 6. Except the only thing that's going to be different is this word. That they're going to ask you things like, what is the probability that the average time taken to do something is such and such? What is the probability that the average grade in this class is such and such? Whereas before in chapter 6, they wouldn't have said what's the probability that the average time taken to do something is such and such. They would have said, what is the probability that the time taken to do such and such was this? That one word is going to make an enormous difference. Okay? I'm going to erase this. You guys will need this.
No?
I'm asking you. You don't
I
need
mean, but I didn't write it down.
Yeah,
Oh,
let me
okay.
just jump in.
Write it down, write everything.
Just theory. This is in your book.
There's really nothing wrong with that. You want more simplified.
So we've lost our student, our online student.
No, you didn't talk to this morning, Chuck. Let me take these pictures.
No, you won't see they have the recording going on now.
But the laptop isn't there.
Oh, they must
it
record it
doesn't
to
work.
send the
Recording
video.
is
Based off the Senate.
Oh.
Oh,
That's what happened.
oh, so there's recording and sent it to her.
Yeah.
Okay.
I tried to Skype the last week. I couldn't. He said it wasn't. He said he recorded and then
But you know, nobody got my permission to record me.
What is it? This 303 for real?
Man,
Mr.
yeah.
Carter, is anyone recording me? Who's recording me? Y'all should let me know that I'm being recorded.
Now, would you have to assume from this point on? You would always assume in public that you're being recorded.
That's right.
That's an assumption you have to make. Yeah.
You can't say who's recording.
Have to.
Recording.
Because when people were making noise about the video cameras that were being put up around the city, I'm like, the CCTV, you have no expectation of privacy in public. You have no expectation of
Well,
privacy in
exactly.
You
public.
don't have no privacy in your own house.
Wait.
If Google could find me in the ghetto,
No,
y'all
you
really
can't.
think
No,
your
you can't,
privacy?
but
They ready to
about
shoot us
3
in
years
the
ago, 3 years ago, I remember 3 years ago I was in New York, and we were trying to find this place on the corner of 23rd and 23rd and 4th Avenue down in Chelsea or something. And we were able to take Google and we were able to drill straight down to the front of that store. And so you saw, of course it wasn't in real time, right? It was like a, I don't know, 16-hour delay or something. But you were able to see the people who were in the front of that store at the time that last photograph was taken. That is
Now that's it.
amazing.
They could see you just like that.
You could do that.
So
I know
imagine
some-
I mean,
if
I
they
saw-
put
I saw a
weapons
map.
up there. Imagine they put weapons up there
When
of
we look
mass
for our
destruction.
properties and buy, that's what we do. When we cannot locate our properties, that's what we do. We Google it, the area, and we locate our properties like that.
That's fine. I love that idea.
Oh, just go.
I love this ability to use technology to do these
I
sorts
love
of
it, but
things.
then it also could be damaging.
It
What if you put weapons up there?
It could, but you know,
Hide
but
lasers.
you know, don't you say, but don't you, wouldn't you agree, at least I would think that anything that exists can be used for good or bad,
Yeah.
right? So
But it's the human mind.
That
that
is.
has
Even money
the
and
choice.
that's the only dangerous thing, you know.
Yeah.
That's the dangerous thing.
Because when they ready to
Right.
eradicate the
Right.
Bahamas,
Which
they
is
also
correct.
run big laser come on our country,
Oh my
big
God.
magnifying glass on us. They all locked up.
Mhm.
Oh, y'all locked up?
Hey.
I was able to Google where I was staying, right down to where the windows was.
Listen, my BlackBerry, when I get home, and I go onto Google,
And you turn your hotspot on.
but I always keep it on, right? When I go onto Google, and when I go onto Facebook,
Tells you you're
it
traveling.
tells
Tells
you
everybody
you're
else.
home.
Yeah, you
No,
know
it
that
tells
you have to
oh,
set
you're
it
home.
up.
Where are you? You're home.
Yeah.
Yeah, some people have said, oh,
This
he was at
my
the
phone
airport.
is telling
He was
me.
eating at Luciano's.
Yeah, I
Yeah,
think
so you
that.
where my phone so
He
used
was
to my
out there.
routine.
Yeah, why is
It
do
tells
that?
me where I'm traveling in the morning
Yeah.
and then my Via point after that.
I turn mine off. Ain't nobody needs to know what
But my
I
coworker got robbed like that, you know.
We had a
She was on Facebook talking about she was going on her
Oh,
way to the
who tell her?
airport away.
Who tell us
But
that?
she always talking every day.
You don't
And
know.
she going to
That's-
Luciano and she got held up, all the money going
That's
down,
what makes you
stolen.
don't. Yeah, that's what makes you don't.
You don't
I
know.
mean,
I'm like, seriously?
Wait a minute, she was posting that she was going away.
You don't tell
Yes.
people when you traveling.
And somebody
Yeah.
That's the
robbed
thing
her
about
at
my
gunpoint.
cousin.
You don't even tell people when you
At
going out.
gunpoint.
That's
Okay.
why I don't let you know.
No, but we had a fraud seminar. People wasn't saying I'm going here on that day, but what they were doing instead is they post a picture
Pictures, right.
saying where they were.
And then,
I'm in Canada, this and that, and when
Then
they
the
come
next thing,
back, the
the house
house was
empty.
empty.
Okay.
yeah.
So let's okay. Let's.
Because they didn't realize, like,
let's
you
get
post a
back.
picture on day one, but then you'll be on vacation, what, 7 or 8
8 days?
Okay.
You
So-
post pictures when you come back, eh?
For the sampling distribution of the
Vacation
mean,
was fun.
right? For the sampling distribution of the mean, because we're going to be talking about sampling distribution of the mean and of the proportion. But let's talk only about the mean for a moment. For the sampling distribution of the mean, the procedure for finding probabilities related to the sampling distribution of the mean is going to be exactly the same procedure we used in chapter 6. Nothing is going to change with the exception of how we calculate z.
Okay.
Okay? Everything else is going to be the same.
And the word.
So our z calculation then is going to be z for some x bar, right? Which is going to be x bar minus mu over the standard error of the sampling distribution. This is the thing we need to be very concerned about. What is the standard error of the sampling distribution? Okay?
Same thing as the standard.
So it's the average of the standard
Same thing as the standard deviation.
It is the same thing. It works the same way,
Okay.
but it works the same way, but it's defined a little differently because it's shaped much differently than the standard deviation. Okay, the standard deviation simply says, here is the mean plus or minus these things, plus or minus these things, plus or minus these things. The standard error of the sampling distribution does that same thing, right? Standard deviation says, here's the mean, plus or minus 1 sigma, plus or minus 2 sigma, plus or minus 3 sigma. 3 minus 2 minus 1, 1, 2, and 3, right? Now the standard error of the sampling distribution is a little different. Standard error of the sampling distribution says, all right, here's the mean of all sample means. Right? Here is one standard error minus one standard error. Here is one standard error. Here is two. And here is three. The distribution rate is much bigger.
Wider.
So they look, but it behaves the same way, but it's just that the intervals between these things are not like they were in the standard deviation. Okay? So what that means then is that now we're starting to get very, very sophisticated. Because now we're going to have to look, we're going to have to use prowess, right? We're going to have to use prowess. We're going to have to think seriously about these problems, and we're going to have to make some decisions. And only you can make these decisions.
Oh God.
I'm going to be there to make these decisions for you. You're going to have some decisions to make. So this part of the class becomes even more proceduralized, right? We all work in banks or insurance companies or whatever. Procedures, right? I always tell my staff, I can always protect you if you follow procedure. Don't.
Deviate.
I can't.
Yeah.
I can't do anything. So let's look at this, because this is really the only thing that we have to be concerned about that's different. When we calculate the standard error, right? When we calculate the standard error of the sampling distribution, that means we're going to be concerned with that. We're going to be calculating the standard error, which is symbolized by this, right? If the population is a finite population, then the standard error of the sampling distribution is going to be defined as n minus n over n minus 1 times sigma divided by the square root of that. If the population is infinite, then the standard error of the sampling distribution is going to be defined as sigma divided by the square root of n. How do we know if the population is finite? How do we know if the population is finite? If the population is finite, then n for the sample divided by n for the population is going to be less than 0.05. If the population is infinite, then, greater than, the wrong one, greater than. If the population is infinite, n divided by uppercase N for the population is going to be less than or equal to 0.05. So what that means, because this, we really have to think about this, right? If the population is so large that this sample you chose is no more than 5% of it, we can say that population is so big it is infinite. But if you have a population, right, that has your sample is more than 5% of that population we're gonna say is small. Right? So it's finite, meaning we know where that population starts and ends. This algorithm is going to be our guide. Right? That is what we're going to use to determine how to define this. So that means we would think very carefully about these problems going forward.
Like that.
I would suggest, 'cause I don't think your book describes it
I'll
like
just
that.
wait till you finish, you know.
Yeah. And just for fun, we call this the finite correction factor. Alright, so let's do this problem. According to a report in the Wall Street Journal, according to a report in the Wall Street Journal, of 3,500 households reviewed, it takes the average household it takes the average household 21.7 hours. It takes the average household 21.7 hours to do its state and federal income tax returns. To do its state and federal income tax returns. If a random sample of 36 households is selected, what is the probability that the average household will spend Part A, between 19 and 20 hours to complete its taxes. what is the probability that the average household will spend between 19 and 20 hours to complete its taxes? Okay. So, favorite word, procedure, right? Let's establish a procedure. Before we can do anything, right? Before we can calculate any probability, we need to know what the standard error of the sampling distribution is. Now, some problems will, as part A, to try to guide you through the problem. Some problem will say, what is the standard error of the sampling distribution? That will tell you, this is a sampling distribution. Because if you read discretion, listen to discretion, the only difference in this question versus one in chapter 6 is what? This word average. What is the probability that the average time, as opposed to chapter 6, it would say, what's the probability that a household takes more between 19 and 20 hours? Now it's asking what's the probability that the average household takes between 19 and 20 hours, or what's the probability that the household takes an average of between 19 and 20 hours. So that means now they're asking you a probability about X bar as opposed to a probability about X, right? If this particular question didn't at first ask you for the standard error of the sampling distribution, so you have to know that it's best for me to calculate that first, because I'm going to need that throughout this problem. And depending on whether or not that standard error of the sampling distribution is finite or infinite, will give you a very messy set of workings later on, or a very clean set of workings. Because if it's finite, you use that finite correction factor, you don't want to be using that throughout the thing. You want to calculate that once, right? So first thing, figure out whether or not this population is finite or infinite. So, is n, so what is the ratio of n to n? What is the sample size? The sample size?
36.
36. And what is the population size?
3,500.
3,500. So what is that equal to? I guess approximately 0.01. Yeah?
You're
Okay.
gonna show us that. Show us up.
No, I prefer the long,
No, I said you don't gotta show us up that much, but
Oh.
I assume it's 0.01.
What do you mean show
Because
you
you
up?
know it out your head.
No, because that's 36 divided by
I know,
3,500.
but
Yeah.
I mean, I'll bring
You know
you
you
tip
quit.
like
You know
yours.
you
That's
quit.
what I mean.
It's like, oh my God, seriously?
Okay. So really, the rule is what? If lowercase n divided by uppercase n is less than or equal to 0.005, then that has to be
Infinite.
infinite. So this is infinite. So since that's an infinite population, that means then that your standard error is going to be defined only as sigma divided by the square root of n.
Right.
So what is sigma for the problem?
They didn't realize it's
Did I not give it to you?
no.
Oh, I probably didn't give it to you. It is here though, I just missed it. Yeah. Okay, so it says, according to a report from the Wall Street Journal, 3,500 households reviewed, it takes the average household 21.7 hours to do its federal and state income taxes with a standard deviation of 6 hours. So right there is with a standard deviation of 6 hours. Okay? So this is going to be 6 then, divided by the square root of 36. So that's obviously going to be 1. Square root of 36 is 6, 6 into 6 is 1. Okay. Good. So now we can look at the probability for that. So probability says, what is probability that, so it says in a random sample of 36 households selected, what is the probability that the average household will spend between 19 and 20 hours? So what is the probability then of 19? That's unequal to X bar, that's unequal to 20. So, we need this, we just need Z for X bar equals 19. So it's 19 minus, what's the mean? What is the population?
21.7.
21.7 divided by the standard error of the sampling distribution, 1. So what does that work out to be? Negative 2.7. And now we need 20. So what is C when X bar is equal to 20? That's 20 minus 21.7 over 1. Negative 1.7. Just go plot your distribution. Now this is mu X bar. Right? It's made of all the sample bits. And so negative 2.7, negative 1.7. What are we looking for?
The space in between them two.
So what's the area for 2.7?
4.965.
0.4965. And what is 1.7?
0.4554.
Is that right?
Yeah.
Take 2.965.
0.4965? 2.7?
Put down
2.7 and 0.
2.7.
Are you looking at 2.7?
On the
First
Oh,
one.
and zeroing, oh.
And 0,
Yeah.
So we take away Mr. Rose?
Uh-huh.
Yeah, so we only just want that piece in there, right?
Yeah.
This is included in that, so we need to take that out.
Okay.
What are you doing?
So that's gonna be 0.4965 minus 0.4557 is equal to
0.0408.
okay. See, once we learn that procedure one time,
It was a simple one.
Like you say, if you
I'm
don't
not-
need any help,
I'm just talking about the procedure.
yeah.
Once you proceduralize it, then the steps become very mechanical. Just plug in
So you
these things,
figure out
plug
the
in
first
these
one.
things, plug in these things. I have a guy to work that runs some scenarios for me for my verification center. And he said the other day, we have a new guy that came in and he has to run some of these scenarios to determine like what's the probability that this discrepancy belongs to Scotiabank because they didn't they didn't stamp that strap, right? And the guy who came in, he was like, Jesus, this is taking me forever. And the other guy was like, I could do this in my sleep. Right? Because, and he's only been doing it for about a year. But because he has procedure so down pat, it's like that. He could do it without even thinking about it.
Because it's like his blood.
0.4554. What did I write? Oh, 7 up here. Okay. Part B.
Hold on, let me make sure.
The answer that I
That's right.
changed.
No, that's all right.
Oh, there?
He just didn't.
At least.
No, that's point
That's
0411.
It's 1.7.
554, yeah.
the-
So what is this?
the
What should this be?
1-1.
411.
Yeah.
I get the same answer.
No.
Oh.
Because it's
0.4965 minus
554.
0.4554.
So hold on, the answer
Yeah,
that I
that's what
changed.
I'm saying. You have to change.
Okay.
Ooh, I don't like writing pen.
Part B. At least 23 hours to complete.
Needs 23 hours.
To complete.
Thank you, Mr. 9-year-old. Somebody.
Oh, geez.
At least 23 hours to complete. Now, if he raw you for showing him up, you let me know.
Oh.
Let me know. Take care of him.
Get him.
Okay, so this one, who wants to take this one? We have the procedure already, so.
Probability of X. At least 25. At least. So what it is? What that is? What?
Greater than.
Greater than or equal to? No. Is it greater than or equal to 20? 23? Because I honestly I just forget how you just put that. Yeah, if you go left or right with the triangle to the mode
B is
piece,
at least 23.
that's the high triangle.
Just think about it as an arrow.
Mhm.
The R line.
Just think about it as an arrow. If you want at least 23, that means you want to go at 23 and more. So it's gonna point that way.
Mhm.
If you want to be no more than 23 or less than 23, go to
Left is less, right is greater. Oh, I think of it like that.
Okay.
Okay, but is this right?
Yes.
Yeah.
Yes?
Yes.
Y'all just got this whole question wrong.
What?
That needs to be X bar.
Oh.
Oh my God.
That question would get marked.
Oh, I was
Mr. Roll,
wrong on
Mr.
the
Roll,
first
Mr. Roll,
one
Mr. Roll,
too,
Mr.
but I
Roll.
missed it.
See why?
I wouldn't even go any further marking it, it would just get marked wrong.
So we could define that as 0.5.
You mean that because you missed that one dash?
Yeah.
Yes, no, I wouldn't even grade the question anymore. If you get that wrong, then that question is wrong.
But Mr. Rule, what if you have the right
Average.
word?
Is it
Listen
He
to
know-
me, listen to what I'm saying, listen to me.
Going on
He said
over.
Once I get to this point and that is wrong, there's a big X going to that whole problem. I won't even grade it any longer because what you're telling me here
Is that
is
it's not the
wrong.
average.
Yes. Because you're not even trying to find the probability of an average.
That's
So
what
be
I'm
very
hearing you
careful
say, average.
with this, right? Be very careful with this going forward because you have to define that properly. So go ahead. So now Z.
C, X bar
C for X bar of 23.
Yes,
Right,
sir.
yeah.
is equal to 23 minus the 21.7 over 1. Minus 21.7. 1.3.
Okay. Plot mu X bar. Make sure you put mu X bar here.
Yes, sir.
1.3.
0.4032.
What are we trying to find?
We are finding to the right.
In the tail.
Yes. At least I know what direction I'm going.
What is this?
0.4032.
Okay.
So you're minusing that 1.5.
0.5 minus 0.4032 is equal to
0.0968.
0.0968. Okay. Part C.
It'd be so easy when we doing this in God.
Yeah.
I know, right?
And anybody else get blind, they don't know.
No more than 19 hours to complete its taxes. No more than 19 hours to complete its taxes. Let's go. No more than 19 hours.
Probability of X bar is less than or equal to 19. Okay, somebody take it over.
Come on.
Okay,
Anyone?
Z X bar
C X bar 19
19.
equals to 19 minus 21.7 over 1 equals negative 2.7 divided by 1. I do it the long way, sorry, it's
Negative
negative
2.7.
2.7. I just do it the long way.
That's fine. That works for you.
Try.
We have that, eh?
Divided by 1.
We have that one.
We already
Yeah,
did
but
that.
Yeah, we ready to know.
Yeah,
Oh,
see?
2.7.
Just
Yeah,
wasted
take
30
time.
seconds, but that's okay. We didn't notice we had it. Um,
So,
0.4.
0.5.
so what are we trying to find?
To the left.
No
Everything to the
Left,
left in the
to the left.
tail.
Left tail?
So
Uh-huh.
0.5.
You already have this, you
2.7.
said?
Yeah,
Yeah, but just 0.4965.
We have that already, yes.
Correct. 0.4965. Uh-huh.
So then you say 0.5 minus 0.4965 equals to what, guys? Minus 0. I'm sorry, I just open.
0.0035.
0.0035. Okay. And part D. Between 18 and 19 hours to complete. Yep, between 18 and 19 hours to complete.
Okay, probability of 18 less than or equal to X bar less than or equal to 19.
Okay. So C for X bar of 18, do we have it?
No, we
No, no 18. So
18 minus 1.7 over 1.
3.7,
negative 3.7. And then
And we have 19.
we know we have C for X bar equals 19, right? That is
Negative 2.7.
negative 2.7. So we're gonna plot mu for X bar. So that's all the way up the charts. We're gonna bound this, negative 3.7 and negative 2.7. So we want everything in the tail and beyond, right? So from mu to 3.7 is gonna be what?
you say it's from
3.7, 0.49,
3.7, because it's above 3.
No.
So give us a
0.5. 0.5. The highest thing in your table is
0.5.
3.09.
Yeah.
3.0.
So
So
this
to
has to
do
be
0.4.
0.5.
And what is 2.7?
0.5.
What is 2.7?
Oh, 2.7.
0.49.
4965.
Okay, so what is this gonna be?
That's 0.5 minus the 0.4965.
Same thing.
Yep, same thing, 0.0035. Okay, sick for that problem.
So Mr. Rule, just a reminder, anytime it goes over 3.9.
3.0.
3.09.
3.09, then you go with 0.5.
4.5, if you use 0.499. 0.4999, that's fine.
Okay, alright, okay.
Okay, so to find something a little bit more interesting than that. See. done? Okay. Transactions processed by a payment system. Transactions processed by a payment system. Are completed in the order they are received. Unless a gridlock occurs. At which time the system runs a resolution algorithm to reshuffle the payments. Any of you who work for banks process payments? This is this problem is about, this came from the Canadian Payments Association actually, but we have the same type of a process. The central bank runs the payment system, the high value payment system for the country, like BEST, RTGS. And what happens is when you have 7 banks making payments to each other, sometimes a gridlock happens. Scotiabank is trying to make a payment to Royal, but Scotia needs to make that payment for $10 million to Royal. Just as an example, Scotia doesn't have $10 million on its account to make the payment to Royal, because Scotia is owed $20 million from Citibank, and Citibank hasn't paid yet. Citibank is waiting for a payment from Bank of Bahamas. Bank of Bahamas hasn't paid yet because it's waiting for a payment from Fidelity. Right? So all of these payments are gridlocked because as Scotia is waiting for its money, but all these payments are gridlocked because Fidelity hasn't made the payment. They take right. So what'll happen is the system will look at that. The system will say, wow, these payments are not moving because all of these payments are waiting for somebody to pay. So it'll look and it'll see, oh, Fidelity has this payment.
Is it like a matching system?
Fidelity has this payment, not really. It's the net sets happens later. So Fidelity has this payment that's pending. So what we will do is we will assume, let's look at Fidelity's account. Does Fidelity have enough money? Yes. So the system will temporarily, automatically approve that transaction and reshuffle the payments so that Scotia can get paid. Now later on, Fidelity has to actually approve that payment, or that payment, or that whole process gets unwound. But if that doesn't happen, then all these payments will end up being gridlocked, because you know what is holding up the payment. You know why Fidelity can't make the payment? Yes. No, because Scotia owes them.
Yeah, somebody over there.
You see? Yeah, it's a
Even
whole.
though they have the money on their
Yeah, it's a whole
accounts.
gridlock.
Oh,
All of these
because
banks
the
are
original
waiting
banks
for
owe
somebody
each
else to
other.
pay, and if one of them doesn't make the payment, none of them can get paid. So we have to go and, so that's just that algorithm which was actually designed by BMSA. Looks at that last process and says, that Fidelity payment is really being held up by a Scotiabank payment anyway. Scotia does have the money.
That's pretty
So
smart though.
it's easy. It's actually quite
That's
easy.
a good way to track too.
It's actually quite easy. Actually, the Canadian Payments Association just adopted our algorithm. I went to Canada in April to set this up for them. They wanted to use our
Go on
algorithm
there. Go on there.
because it's very efficient.
So how much they
Oh, we
pay?
need more people like you, Mr. Ray.
I know, right?
They, you know, central banks, the funny thing, central banks usually are courteous to each other. They don't usually charge each other.
Wow.
No
Okay.
such thing
But at
as
least
free.
it's
But then at least you didn't
Yeah,
go
that's true.
get
Bahamas
risk.
thing gets up.
But you see, we might need
Right.
that.
Yes, Mr. Gargan saying there's no such thing as a free lunch.
Yeah. There's no is free lunch because they will return the favor in another way.
Yeah.
Eventually.
Yeah. So going on. A systems analyst.
This after we shuffle the payment?
Yes. A systems analyst selects 150 payments from today's incoming transactions. And finds that the system takes an average of 4.2 milliseconds. That the system takes an average of 4.2 milliseconds to process each payment. With a standard deviation of 1.65 milliseconds. What is the probability that the average payment takes （Part A. No more than 3.8 milliseconds to process. No more than 3.8 milliseconds to process. Okay, what's first?
Probability
Procedure.
Oh.
Procedure.
Yeah.
Start with procedure. What's first?
Determine if it's infinite.
Determine if it's infinite or finite. To determine if it's infinite or finite, we need to know two things: samples and population. Do we have both?
Yeah, they say they have a sample because they say select 150 payments from today's.
Do we have the sample, do you have the
We don't have the
population?
population.
Do we have both?
No.
So we do not have both, meaning that we cannot determine that ratio of sample to population.
Right.
So whenever we don't have the population data, we will always assume that the population is infinite. Okay? If you're not given the population data, you have to assume that the population is infinite.
If not given a sample and population together, then you assume that it's infinite.
Don't write it like that.
Right.
Okay.
It's just
If not
that if
given
you
the
don't- if you're not given the population size,
Assume.
then you have to assume the population is infinite. So that means then that so what's the next step in the procedure? Figure out the standard error.
Standard error. Yeah, standard
So the standard error then, for the standard error is simply sigma divided by the square root of n. So what is sigma?
1.65.
And what's n?
150.
150. So what does that work out to?
$7.42.
No.
No.
0.1347. 0.1347.
Square root of 1.
No, you just put in 1.65 divided by.
Hold on.
165.
Alright. 1.65 divided by square root.
Okay, so what's next?
Okay. The next step is P
It says
bracket.
no more than
So now
3.8 milliseconds, so probability
X
X
bar
X bar is
less
less
than
than
or
or
equal
equal
to
3.8
3.8
milliseconds.
seconds. Well, 3.8.
3.8, right? Okay. Uh-huh.
And then C's X bar 3.8.
Mm-hmm.
3.8 minus 0. 150.
No?
Hold on.
3.8
minus
minus
4.2 milliseconds. Sorry. Over 0.1347.
Mm-hmm.
Are we rounding?
Negative
2.976.
2.976. Sorry, four
2.97.
places. Sorry, 2.969.
How many
How many
places are we
places?
going?
Two.
Two. Yeah,
right?
two.
2.97.
Yeah, negative 2.9.
Negative 0.297, sorry.
Negative
2.97.
Because we've been doing this long enough now. We know Z has to be two decimals. Okay, so negative 2.97 is gonna be here. What are we trying to find?
Everything to the left.
So,
In that table.
just in the tail.
Yeah, so
So it's
0.4985.
5.
Uh-huh.
0.5.
So 0.5
Minus
minus
0.495.
Mhm.
Oh my god.
0.0015.
Yeah.
0.0015. Good. Part B. What's the probability that the average time? Oh, so they said average payment takes. So part B is at least 4.0 milliseconds to process.
is 4.0.
4.0 milliseconds. So the probability of
X bar
X bar.
greater than or equal to 4.0. Okay, so Z X bar 4.0 equal 4.0 minus 4.2 all over 0.1347.
Negative
Negative
149.
Negative
1.48.
48.
48.
48 or 49?
48. 48.
What's the number?
It's 1.48.
44.
1.484.
Yeah, so it's 1.48.
Okay.
Visualize.
What are we looking for?
1
What are we looking for?
to the right, to the right, so we all that to the right.
1.48.
Okay.
Negative 1.4 and 8 is 0.306.
0.306.
point four,
306.
4306, sorry for that. 306.
This is 0.5. What do we do?
0.5 plus 4.4306 is equal to 0.94, 0.9306.
Okay. Part C. Between 3.9 and 4.5 milliseconds.
Probability of 3.9 less than or greater than x bar less than or greater than 4.
That's not equal to.
Equal to, my bad. Equal to 4.5.
Okay. Do we have any of these things yet? No?
No, we X bar 3.9.
X bar
3.9 minus 4.2 over 0.7.
That's negative 2.23.
Yeah.
Okay.
Equals 4.5 minus 4.2 over 0.1347.
2.22. 2.23. 2.23.
Yeah,
Same.
same thing.
Okay, so negative 2.22.
Yeah, and positive 2.2.
Positive 2.2.
Fine. Everything in between there.
Finding everything. So what is 2.22?
0.4871.
Add all two together.
871.
Mm-hmm.
742.
0.9742.
Questions? Chapter 7 is fairly straightforward. It's the procedures, we learned the procedure already, so it's not like we're learning anything new.
Okay.
Just trying to make sure that we determine whether or not we know the sample, so that we can figure whether or not the population is infinite. Sorry, whether or not we know the sample size, so we can know whether or not the sample population is infinite or finite. Then that'll allow you to calculate the correct standard error. And you just use the standard error in the Z calculation and everything else is the same.
Yes, Anyway, question, so will we be having any, I mean, are we gonna do a question on finite now? Or will we
No.
have a question on that?
Yes, possibly. Then just use the correction factor.
Yeah.
I mean, you mean you would find it difficult to take
No.
n and subtract n and divide it by n
N.
minus 1 and multiply it by this?
No.
Okay. Let's hope at this stage. I mean, they come up every now and again. They're not very frequent. But every now and again you'll find one that has a correction factor. Okay. That's why you do the test to figure out which one to use. Okay, so let's look at this question. There are 500 employees in a firm. There are 500 employees in a firm. 45% of them are female. A sample of 60 employees is randomly selected.
Yeah, please.
Part A. What is the standard error of the sampling distribution?
I mean, sigma over x bar. Then you put equals.
Over x bar? Sigma over x bar?
I mean sigma x bar.
bar.
Sorry.
Oh.
Sigma x bar equals sigma over square root of n. Small n. Because it's sample. Equals. This is true value. 6. Yes.
N is 60.
Yeah.
Equals the square root of 60. I guess sigma is 45. Oh no, I lied. 500.
500.
500. Sorry, this wasn't okay.
Square root 60 was
Square root 60.
I will read the question again. There are 500 employees in this firm.
Hold on,
Infinite,
read it,
infinite.
Mr. Rowe.
There are 500
There's a
employees of this
population.
firm,
And then there is a thing of
45% of which are female. A sample of 60 employees is randomly selected. Part A, determine the standard error of this sampling distribution.
The n it's the finite.
It gave us
This is the
number.
problem, because you are refused to follow procedure. We don't even know if it's finite or infinite yet, because you haven't checked.
No, let them check.
Since you're gonna say the what is the standard
It's infinite.
But then it
They asked
Still
if
have
you
to
know the
ask.
standard error.
Check.
You need to know.
Okay.
You need to know
Still
what
have
the-
to check.
I was
It's finite
checking.
or
You
infinite.
have to check.
Yeah,
It's the
it's
procedure.
infinite.
right?
It's infinite. N over N.
Is N over
Big X.
N over N.
I
You
apologize.
said big X?
N over N.
N over
I got a big
N?
X with you.
60 over 500 gives you 0.1.
0.12.
2. Yeah.
So this is going
This
to
is-
be finite.
My
That's
bad.
quite big. The ratio of the sample to the population is quite big, so that sample is very small. Okay? Now that we know the population is finite, what do we do?
Now we use that formula.
Hey, at least I was trying.
Yes, at least you were trying. Oh, Elkin
Good
shouldn't harass you.
You
Me?
understand?
I did not harass her.
I know Elkin, it don't
Thank
hurt.
you, thank you. You put me on me.
Okay, so what do we do now?
Yes.
Work it out.
Okay, so what am I working?
Say work it out.
We do the
using the
square
finite
root.
formula.
Yes, the
Finite
square
correction
root.
factor.
Okay, so we're going to calculate the standard error.
Yes.
What am I writing?
But I think I missed X.
Sigma.
Sigma X bar
Sigma
X bar
equals square root.
sigma over square
No,
root.
equals square root.
Oh, sorry.
N minus small, big N minus
Finite.
small n over big N minus 1 over close
Times.
Not
bracket.
over.
Yeah.
Okay. Sigma over.
Sigma over N.
Small n.
N, yeah.
Square root of small n. Oh.
Jesus. That's supposed to be
Yeah.
big N
Yes.
minus small n
Yes.
Right
over
next to finite.
big N over what?
Yes.
Because he didn't have an over thing.
He
Small
has
n? That's
yes.
what
big
I
N minus small n over big N minus 1.
said. Okay.
Yes, I remember that.
He did not have that on the bottom.
Yes.
Yes.
Yes, he
I didn't
did.
have the square root.
Check your picture.
Yes,
I
he
did.
did.
Even me up. So check your picture.
Right.
I know it.
That's why you better write down, take a picture. Try right down.
Okay, let me move on.
Yeah,
Yes.
sorry.
And Miss Max?
So,
Now, next
so
is
square root of the 500 minus the 60. Square root 500 minus 60 over 500 minus 1 over
bracket.
what that is now?
Sigma.
Sigma.
No,
Sigma.
but hold on, but the
We
sigma.
got it.
Big,
You
yes.
don't have sigma.
0.12.
Gotta
No,
put it
No.
there.
sigma is
Still gotta put it there.
Yeah.
Sigma.
sigma over
Square root of
Square
of 500.
yeah
60.
60.
Made
60.
That's a small n.
60,
N.
yeah,
Small
small
n.
n. But I think don't we have sigma? Sigma, which is the 0.45. No,
Stop guessing, man.
I don't know.
Another exercise.
That's very good observation. We're going to stop guessing. We're just guessing. We see numbers, and so we say, oh, let's just throw it
Put the
somewhere.
numbers in.
Let's just put it somewhere.
We don't have to.
Okay, am I heading in the right direction so far?
Well, you put in n, and you put in n,
Right.
you put in n, and you put in 1.
Okay, just wanted to make sure.
So,
Yes, we need the thing. We need the stamp.
okay, so how do we get it?
Okay, so
Gotta rearrange the formula, eh?
minus 60 over 500 minus 1, which is 440.
You gotta solve for
That's what I'm saying.
Yeah,
So
but solve
square
for
root
it.
of 440 over 499.
That's not reasoning.
No? What's you gonna do? We're gonna minimize
That's
that.
why I stopped talking.
Yeah, I see. You listen.
Because this is a classic example, Yahima, this is a classic example. There we go. Classic example of, and that's why I just let you guys go on for a little bit. It's a classic example of how when we move on from something, our brain shut down,
Yeah, yeah.
all what we've done.
You just have to do it normally.
You read this problem, and I ask you a question. Is this problem not binomial? Is this problem not binomial? Is this problem not binomial?
Yeah. Because it didn't say average. It didn't say average. So yeah.
They ask you no. They ain't tell you nothing yet about no averages.
No.
They haven't said anything yet about any averages. The only thing they said to you is that this company has 500 employees, 45% of them are female.
Sample of
The
60.
600.
And there's a sample of 60 of them taken.
Randomly selected.
Now all they're asking you, what is the standard error of this distribution? Is this question not binomial?
Yes, it
It
is.
is.
This question is binomial. The question is binomial. There are 500 employees, you choose an employee at random, is that person male or female? That person is going to be male or female. Is there are there at least 2 consecutive trials? Yes, there are 500 of them.
Right.
What's the probability if you choose a person at random, that person is going to be female? It's 45%. Are the trials statistically independent? Does the fact that person is male affect the fact that person is female? No. Does probability of success remain constant from trial to trial? Yes, it
Yes.
never changed to 45%. It's simple. We have to remember
Yeah.
these.
So we ain't even need to do all that.
Okay? We have to remember these. So, now that we've gotten over that hurdle, because that was a hurdle, the reason that they asked you in part A for the standard error of the sampling distribution is because it is a sampling distribution. But it's a sampling distribution because the problem is binomial. Because they asked you for a proportion. So, this now we're moving on to the standard error. We are moving on to the sampling distribution of the proportion. When you are asked a question about a probability associated with a binomial, right? So remember these 2 things. If the question is a binomial, and the question is sampling distribution, right? Because they asked you for the standard error of the sampling distribution, then that means this has to be proportional. That's why I didn't let you guys go too far. We would have wasted too much time. Right? So, the same procedure exists for determining whether or not the population is finite or infinite. That doesn't change. The only thing that does change is what is the sampling distribution? What is the standard error of the sampling distribution?
Mr. Rowe, can I ask a question, please? Average is not in here, so that's something that, because there's nowhere in here, but you said sampling distribution and proportion. So the proportion would be able to tell you whether it's finite.
No.
It
This
tells you
question-
whether it's binomial.
Yeah, this question, when we talk about sampling distributions, the sampling distributions have got to be of the mean or it has to be of the proportion. If it asks you any question about the mean, right? If it asks you any question about the probability of a mean, then clearly it's a sampling distribution of the mean. Now, this question could have easily been binomial, just plain old binomial, except for the fact that it asks you for the standard error of the sampling distribution. That is the only thing that told you that this question was a sampling distribution, because it asked you for the standard error of this sampling distribution. Otherwise, you would have treated this question as if it were plain old binomial. If it asks you for the standard error of the sampling distribution and the question is binomial, then that means that the question has to be proportional. Okay? So, we go through the same procedure, determine whether or not the population is finite or infinite. Right? Then, once we know if it's finite or infinite, we calculate our standard error of the sampling distribution of the proportion in this case. So our standard error of the sampling distribution of the proportion, P bar, right? P bar is going to be considered the proportion. Standard error of the sampling distribution of the proportion is given by the square root of P bar, 1 minus P bar divided by n. Okay? If this question is also finite, right? So this would be for infinite, right?
So then you have to,
If this question is also finite, we need to use the finite correction factor, where P bar, the standard error of the sampling distribution of proportion is going to be equal to P bar 1 minus P bar over N times N minus N minus 1.
Whoa.
Okay.
Say whoa.
Plugging some things in. Two things, taking the square root, multiplying them together.
I was thinking about.
Lovely. Okay. So this is why, Yehima, this is why you can imagine how messy this will get if you try to do this in your calculation for Z.
Yeah.
So this is one of the reasons why it's always a good idea to do it first. That way you have just a number to plug into the bottom of Z, as opposed to trying to go through all this. So, okay, so now let's look at the problem. Right? So what is P bar? What is P bar? The proportion for the sample.
60. 68.
The proportion. What proportion? What is the proportion?
45%.
45%. They've said the proportion.
45%.
The proportion is what part of the whole.
45.
What part of the whole? That's what a proportion means, right? What part of the whole? So, yeah. So what is it? 45%? So 0.45 times 0. What is 1 minus P bar? 0.55. What is N for the sample? 60 times
500 minus 60.
minus 60
500 minus 1 minus 1.
minus 1. So what does this work out to be? Do the square root and everything and give me that, and give me that.
Oh. And that's 0.0642.
Which piece? This piece
The
here?
first
Yes.
piece.
How did y'all do that?
0.06
Times divide and
Divide
Yeah,
and
that's
square.
right.
That's the easiest way to do it.
You get an error.
0.9390
Yeah.
second piece.
0.9390.
Mm-hmm.
And you times both of them together. 0.0603.
Good, perfect. Just for your idea when you're thinking about you going through these problems, this finite correction factor will usually be somewhere in the 90s. If you get a low finite correction factor, you've done something wrong. These are usually around 90%, 95%, 99%, because they cause very little difference between the infinite and the finite answers.
Okay.
Okay. So that's part A. We have our standard error of the sampling distribution of this proportion. Part B says, what is the probability that the sample proportion of females, what is the probability that the sample proportion of females is between 0.4 and 0.55? It's between 0.4 and 0.55. What's the probability that the sample proportion of females is between 0.4 and 0.55? Where do we go?
Probability of 0.4 less than or equal to X bar.
P bar,
I mean,
P bar, right?
P.
Oh, P bar. Because it's
P bar.
proportion?
Yeah.
Okay. It's less than or equal to 0.55.
Okay.
I think you should have a bound there.
This is the proportion.
Oh, sorry, you are right. They did say for the sample, right? They said
Yeah.
for the sample, yeah. You're right. Okay. Now, we need to be very careful here. Out.
Sorry.
Very
I'm trying to
careful.
work it out, yeah.
Here. Why do we need to be very careful there?
Because they're
It's
probably
on the proportion.
calculated the same way.
Because
It's probably calculated the same way.
of which
Stein?
probably, no. The problem here is that we have to remember.
To do
What do we have to remember?
the standard error again?
No, we have the standard error. Calculated the standard error.
45.
Yeah, right. We calculated the standard error for this whole sampling distribution. That's the standard error for the whole sampling distribution. That's what we did. But what's the problem here? Okay, don't forget. As we move on from chapter to chapter, these things build on each other. We can't forget things we learned before. What's the problem here?
We have to test for curve
We have to test for curve. Why?
to make sure it's.
Exactly, exactly. Didn't we just, in chapter 6, when we used normal approximation to calculate a binomial, we had to calculate curve?
Right.
We had to make sure that this binomial probability distribution was
symmetry.
big enough and tight enough that it was going to be symmetrical. We have to do the same thing here. Because this proportion, we can't calculate this as a binomial, right? We can't calculate this as a binomial because you're being asked to find the probability of between 0.4 and 0.55. That's a huge number of calculations. We have to treat this essentially as if this is normal approximation, so we need to test for curve. Very good, very good. So is n times p, but in this case now is n times p bar
Right.
and n times 1 minus p bar both greater than or equal to 5?
Yes.
Yes, just look at it. N is 60, p bar is what? What's p bar? 0.45? Clearly. And clearly the reverse of that's going to be greater than or equal to 5. Yes. You can calculate it out if you want, that's fine. Okay? So, now what do? We go and we say, okay, well we have that, so now let's calculate z. So we need z for 0.4 and z for 0.55. So z, when p bar is equal to 0.40, is equal to, well, maybe we should write this over here. Z for p bar is equal to p bar minus, sorry, not p bar, p minus p bar over this. Well, we could just write this so that we don't have to write that old messy thing in there. 0.0.
So that's what we need to put before we put the z.
So this is what z is. That is z, right? So now we need to know what is the sample. What is the sample proportion we're looking for, which is what's given to you in the probability. So it is 0.4 minus what is p bar, 0.45. And we already calculated this. That's why we spend the time to calculate it before, otherwise it gets messy. What is that?
negative point two, I mean negative 0.83.
Negative 0.83. And now we need to do for 0.55. So what is, keep putting P in the wrong place, that should be P. What is the probability? We want to see when P is equal to 0.55. So it's 0.55 minus 0.45 over to 0.0603.
1.67.
66.
I mean 66, yeah.
1.66?
Yes, sir.
Okay. So that's poor. Yeah, that's all right.
Yeah, it's right, but now P bar and P keep tracking.
Yeah, you're gonna get used to that.
So
You're gonna
what
get, you're gonna get used to that. The P bar is just for the it was given to you for the expectation for the sample. Anything with a bar is an expectation, right? An expected value. Some books call this the same thing as pi. Okay. Your book likes to use P bar. And P is just whatever the sample proportion is from the probability.
Mr. Rose, can there ever be a time when the answer is no?
Yes, of course. If the answer is no, then we have to wait till we go to 301. Okay. So if the answer is no, then this becomes what we call a non-parametric test. This non-parametrics we learned in 301. But you could get a question and it turns out to be no, and you have to say, I can't do this. Yeah.
So it's just testing to see whether it's greater than or greater than or equals to 5.
That tells you that binomial probability, that all those binomial things are tight, that it's going to start to look like that. Okay, so now we have our normal distribution. This is the mean of P bar. Right? And so negative 0.83 is over here. And 1.66 is here.
We're finding in the middle.
Oh yeah, sorry, finding in the middle, right?
You're right.
So what is 0.83?
0.2967.
And 1.66?
0.4515.
0.45?
4515.
Add them together. 0.2967 plus 0.4515.
Okay.
0.7482.
0.7482.
Okay.
I got a headache.
Today we get the case. The case form.
How is it?
So, what you're going to do for your homework is, because your case is going to be based on chapter 8. So now chapter 8 I suggest you all read chapter 8 before you come to the next class. Chapter 8 is it's a very small chapter. And there's not a lot of new things in it. I mean, in terms of calculations, there's really no new calculations, but the theory behind chapter 8 is very esoteric. I mean, it's a very obscure sort of thing. We're only going to be doing a couple of little calculations and building intervals around things, but interpreting those intervals are fairly involved. So you want to come to class next week prepared. So the things the exam is based on chapter 8. The exam covers chapter 8, so we have to finish chapter 8 as well. So we have to push it. We have to push it.
Push finals to another week.
That ain't
What
final,
finals?
that's the second.
Second.
So for homework next week, you need to come having read chapter 8, right? Then I want you also to do page 2. Everybody has the same book, right? Do page 292, questions 42 to 45, the supplementary exercises.
What questions?
42 to 48. Okay, questions 42 to 48.
No.
And we will also have a quiz on chapter 7.
Next week.
Yes. Okay, so read chapter 8. Do these problems. And quiz on chapter 7. Then we will finish chapter 8. We will start and finish chapter 8. That'll probably take us an hour and a half. It's a very short chapter. Then we will do some reviews, and the exam will be the next week. Of course, we'll have our Friday class and our Friday class to do some reviews as well. Now, I'll tell you, if everybody makes it to the Friday class, we will probably do some review as well as start some new material. But if everybody doesn't make it to the Friday class, we'll just do review. So make every effort to come out. That way we can actually get ahead as well and be a little bit more
Ain't nobody missing.
aggressive.
No. So we ain't gonna
Somebody
have the
is
message.
missing. Somebody was there last night
Christina,
was
or
missing.
Christina at the funeral.
Right.
But I'll let her know.
Okay.
Christina was there last night?
Yeah.
Yes.
She didn't tell me nothing? She was in the work yesterday.
And she was very on point last
Yeah,
night.
it has.
You all were, in fact. Point last night.
Until this Thursday.
Okay, so I'll see you next week.
Sir.
Did you say about the 9?
Oh, thank you for reminding me again. Do you guys want to? If you want to change your class time to 9 o'clock in the morning on Saturdays, we can do that.
We had a lot of yay. Any nays?
I think everybody last night said yes, they wanted
Yeah.
to. Anybody who's not here last night, who wants to leave it the same, makes no difference to me.
Hold on.
I prefer
What?
to come in here for 9 o'clock in the morning to leave around.
But it's 9 to 1?
Yes.
That's a much better
Hi,
time.
friend. Hello.
But the only thing is,
Are
you
you
have
in
to find out
agreement?
which class available.
Helga.
Finding a class won't be a problem.
Because they are.
And I'm here anyway, I'm at
They're
work, I come to
never-
work for 8 o'clock on Saturdays. So,
Yeah, I saw your copy.
Yeah.
Someone has seen this room.
Yeah, but then we do have a vacant room available.
Yehimo? 9 is good?
I'm good.
For 9?
Okay.
Yes.
Now,
And she
that,
said no.
that will even give us an opportunity, just saying, that'll even give us an opportunity that if we are running a little
To
late,
push it,
we can push it. Because we still have chapter 8, chapter
So we
9,
need
and
to push it.
14.
Yeah.
Chapter 14 is a big
Yes.
chapter.
And you will see that in the finals.
Chapter 9 is a big
I
chapter.
don't mind.
Chapter 9 is chapter 9 is quite a chapter actually.
Me,
I feel the pressure.
for me.
But that is really
That's the
Yes,
hypothesis.
rejecting.
Hypothesis,
Yeah.
oh, I can do that.
Let me tell you something. When you
I know
get
it's
it,
simple, yeah.
when you get that, it's like this is it.
I starting to get these better now.
It's like really like 3 very simple rules there. That's why I keep Sorry, I keep hopping on procedure, but the three very simple rules in chapter 9.
Very
And
nice.
once you follow those two rules,
I don't get it.
and you know HO and HA, when you set them, there's a way to go and check to make sure that you're not doing something silly, right? But if you set them in the right direction, there's little tricks you can use.
And I forget the power one.
You ready? Forget what?
I already forgot. Moving on.
Oh.
Don't worry, when you get to chapter 9, you'll have to put in everything from chapter 1 straight up to chapter
Like
9.
how you disconnect this already from the first time. You on Friday.
Okay.
What's that?
6 p.m.
I don't know if I must move or must stay. I don't even know.
Move it.
I don't know if I should go or stay.
Go or say where?
Look at this one.
Because it was a long.
Go on,
I
meet me.
guess you know, so good. You know what's going to start happening. I just want to warn you guys about this.
Because
Is
I wanted to go over there. And then
when we get to chapter 8, the questions even sound a little similar to this, but it's a completely different procedure because they're asking for a different thing. But the questions sound very similar.
You put out
So
upwards,
upwards.
like upwards of this kind and stuff like that.
Yes, but it's not as distinguishable because they're gonna ask you things like what is like they're gonna say things like the average time taken to process a payment is 4.2 milliseconds. What is the 95%? What is the 95% confidence? What is the 95% confidence for the mean? Meaning, I want to know within 95% accuracy that the mean is actually going to vary from this 4.2 milliseconds to some interval.
Yes, we'll get there then.
Yeah, it sounds very similar, but it's a
Thank
very
you.
different question.
Now you could come home.
so that's so
Like Domino's and
Yeah, because this is,
Yeah, today's the 14th.
there's the 14th, so next week will be the 21st, so it'll be the 28th.
That's fine.
So
The day afterwards.
So
Like
we're gonna have to push class, they'll have an
Yes,
extra.
that's fine then.
So that means we'll have our finals June 12th then, instead of, I mean, July 12th.
July 12th.
Okay, then we'll have a class on July 12th.
Yeah, Monday, 6.
Okay. I have to. Something just.
Good help, we follow.
Me, my name.
No, she said that's all right.
I get up at 4:30.
Rich Dairy
Bye.
Queen.
Have a bit.
I'll wait for 5 o'clock.
For
Five, right?
When?
It can be 5. I
When?
get off 4:30 and then go pick up my husband.
When? What day this is?
And you want to say
Monday.
6?
Yeah, by 6. 5
So why y'all won't go
Because they have big tables, tables are bigger.
Close at 11.
Starbucks always full. Yes. Like the red
They have more
Domino's.
table limits,
Yes. The tables
They
big like
changed their
this.
name.
Yeah, you can do it.
Tables big like this.
Ask another question.
I mean, because I be in the mail.
Oh,
I don't remember them people.
Nope, their tables bigger than this.
Okay.
Like 2 of these together is one table.
Oh, wow.
Yeah. Like together like this now.
Unfortunately, I don't know.
Oh,
I gotta see if I can switch my.
Here, I gotta go because my husband.
Yeah, right.
Babysit.
No, one minute, we'll just
Tell me,
chapter 6, 7.
I used to be starving them, man.
No, see, because he worked 27 stories height,
Oh,
for him to use the bathroom, he have to come down 27 stories. And the elevator takes like half an hour to bring you down by Bahama. The elevators are very slow. So it's taking like,
Because they do construction in.
yeah, he up on the roof. He's doing
Child, I
roof.
would never stay in there.
No, that's the
27
outside
floor.
elevators for the workers.
I gotta try.
It'll take half an hour for him to come down out there.
begin at the bottom of the second column. Bottom of the
Anyway.
second column.
I gotta go.
Right, baby.
I gotta know, go try and practice these things we do today.
Yeah, you have to trust me,
Tomorrow.
because I gotta get my daughter.
I'll try to send it back to you. Yes, I gave it to Mr. Bullet. I don't have nobody informed me of that. I don't have any, I don't plan on doing anything. That's just different that somebody has to make arrangements for those things to happen. Because
Really?
you could speak to them downstairs and do all that. Nobody advised me.
I call because I.
Who did you speak with?
Mom, I don't know her name. I was calling mom the older lady. That's the one.
Yeah, you could speak to Miss Bullet.
Okay. Jordan said he told you and you said, oh, okay. Who? Jordan, that's what he told me. So,
Who's Jordan?
I called and I tried to Skype the class. I told Dan, but I was traveling and I wanted to Skype the class. He said,
Jordan didn't say anything to me last week. Jordan came and set up something and he left. He said, one word to me.
Jordan, I really right downstairs. I asked him up and tell him that was a long distance call.
I know my email was working. Somebody sent an email. So, always have some issue. When you knew from weeks ago you had to do something,
Exactly.
you said you had to do something.
It's with the last minute to try to
Always. I couldn't do it, I couldn't. I tried to do it. As if now giving a makeup quiz is just that you just do it like that. That don't take time to prepare a makeup. So I you got remarried. Not remarried, you got renewed your vow.
10 years.
Must be nice. Yes. How many kids do you got?
3.
Made it sound like earlier like it was so
6.
much. So many.
2, 3, 4, 5, 6, 7.
Alright, see you
Next Friday, yeah.
Yeah, okay.
Simple.